Alright, thanks for coming back to the channel. Today's discussion, we're covering how to wire a 20 amp breaker. Single pole, 120 volts, not a whole lot to it. We'll go ahead and get started. First, we'll check to make sure our power is turned off. A good practice, if you haven't used your meter for the day, go ahead and put it on resistance or ohms. You can see, we'll check for, you'll see if it says OL. Some people say open loop, open line, overload. Just know that means that your circuit is open, it's not closed, there's no continuity. Put these two leads together, you can see we have continuity, so your meter's good. Let's move down to volts AC, alternating current. That's what that squiggly line means, because that's what we're dealing with. This is a 100 amp load center, 240 to 120 volt system. We have 120 volts coming in on this line, 120 volts coming in on this line, giving us 240. This is our neutral, and here's our ground. We can start by testing ground to phase A. We should have 120 volts if there were power coming in. We don't. Phase B should have 120 volts. It's reading 0. And we can also come across phase to phase, and we should be reading 240 volts. So that means we're good to work on it. Alright. Nothing to it. There's a little stab on here. Goes on to the bus bar right here. This little plastic tab slaps in right here. Pretty simple. Nice push. It pops right in. Alright, so like I always say, when wiring up devices or panels, light switches, receptacles, anything like that, we start with our grounds first. So we'll bring our ground right here to this ground bar. Nice and tight. Give it a little pull test, make sure it's tight. The reason why I say we start with grounds first is because let's say we wired in our neutral and our hots first. We may have a loose connection somewhere or a short circuit somewhere where this is burning up and arcing off somewhere in the panel or out in the device somewhere, and there's no current, there's no path for that fault current to take. So it's literally just going to sit there and burn up until it just melts itself away or causes a fire, and whatever may happen. You have no protection. This ground is your safety net for this system. So it's just a good practice to go with the grounds first. When you're disassembling something, let's say we're changing this breaker out, I'm going to take the hot off, I'm going to take the neutral off, and then I'm going to take the ground off last. It's the safest way, it's the most efficient way. I've always done it that way. I'll continue to do it that way. I don't even think about it anymore. Even when I know something's turned off and it's disconnected and it's dead, ground goes on first and it comes off last. So let's move to our neutral. We can tie our neutral in down here on our neutral bar. And you can see our incoming neutral at the top of the panel is bonded between these two neutral bars. So this is our neutral bar, and this is our neutral bar. So if you're coming in from this side of the panel, you can land anywhere on here for your neutrals. This side of the panel, anywhere on here for your neutrals. Nice and tight. Pull test. Now if you're looking at your panel and you see that you have grounds and neutrals together on one bar, that's probably your main panel, and it's supposed to be that way. If it's a sub panel, they're supposed to be separated. And your main means of disconnect, your main panel, your grounds and your neutrals are supposed to be bonded. There's a lot more to it. I'll make a video on grounding and bonding. It's not just something I can run through in 30 seconds. So just to know, and if they are separated in your main panel, you can simply just take a wire from your ground bar and pull it to your neutral bar and bond them that way. So alright, before we land this breaker, let's take a look at it and see how this wire is going to go. You see these two tabs right here. You're going to stick the wire in between these two tabs, and when you tighten this screw, you'll see that tab to the right closing in on it. So that's all there is to it. Make sure it's nice and tight when you put the wire in, and that's it. So we'll plug this back up. Tighten it down, give it a little pull test. That's it. So now that we know how to wire this breaker and this circuit, what's actually going on? Let's run through this and make this whole thing make sense. We have 240 volts coming in from our transformer. We have 120 volts coming on A phase and 120 volts coming in on B phase. 120 volts are coming in to this breaker. We turn the breaker on, The current's allowed to flow through this cable, through your circuit, whatever it may be, your receptacles, your lights, whatever it is. Back, it's going to return through this neutral wire, back to the transformer, go through the transformer, come back to your panel, through your breakers, through your hots, through your devices, return back from your devices on the neutral wire back to the transformer. It's the same thing. It never ends. It never stops. It's the law of conservation of energy. The energy can neither be created nor destroyed. It can only be transferred, or it can be converted in another form of energy, which most cases in electricity, that other form of energy is heat. So there you have it. Now, I'll make a video on 240 volt circuits and double pole breakers, but just a quick little run through. Let's say you needed 240 volts to your air conditioner or your heater. Now that we have an idea of 120 volts and 120 volts gives us 240 volts, you would just need a double pole breaker. That way, it'll land on 120 volt on each phase. 120, 120. You'd pop this in. Like that, and you have 240 volts coming directly to your appliance or whatever it is that you'd need. I'll go more in depth on the 240 volt circuits in another video, but just so you have an idea of how it's starting to work, and it's all starting to kind of make sense to you now. So I hope you enjoyed it. Stick around for some more videos. I have a lot more coming. I'm starting on doing a lot of do-it-yourself kind of videos for people that just kind of need to know some things around the house. I'm going to get more in depth on some really interesting things, some transformers, some motors, how motors work. That stuff starts getting really interesting, and I think you'll really enjoy it. So stick around. I have a lot more coming.